Hello, good day everybody. My name is Vin Binongkoli, student Master of Engineering. Today I'm gonna talk about Six Sigma DMIC PACE implementations at Vinca shop. Here is the headline that I want to talk about Six Sigma and then the projects that I want you all to know. Okay, first we move on the Six Sigma methodology DMIC versus DMADV. Okay, as we look here, there is the few difference about the methods that using, which is the IC and DV. Okay, let's look at what the difference here. For the IC is continuous improvement, and then for the DV is the re-engineering, and then for the that one for the IC it's more to the many project available for improvement and then less project available for the improvement. Let's look at the difference belt color in Six Sigma. First, the overall of it is the champion. The champion is the master of all master, which is the project's opportunity, sponsor, and support the project. And then the first tier is the master belt, where is responsible for the overall program in the project. The second tier is black belt, which is the largest project leader, technician expert, and most important is the success of overall program. The third tiers here is the green belt. The green belt is most of them is 80% of all Lean Six Sigma to understand about the project. And the fourth tier is the yellow belt. They train and understand about the methodology and the basic problem solving and concept. Let's move on the company Vinca shop profile. First, this company was built in 2011, which is the natural activity is to supply food or bakery. Second is manpower. In 2021, there is 36 employees that have in the company, which is different background, skill, and competency. Third is joint ventures and CSR. This company was recognized National Skills Agency for the program. And then the fourth is the business model, which is now known about SME or small medium enterprise. And then the number five is company ensure. This company sustaining employee futures working in the organization. Let's look at the proposed Vinca company Six Sigma steering committee chart. The first is, of course, the manager. The second tiers is the belt, black belt, and then the both here is the green belt, one and one positions, and then the many employees are the yellow belt. About the both is 25 employees. Okay, let's move on the defined phase. From the investigations, there are of uh, a lot of demand of the floor in the bread making line. There is data is 3 years from 2011 to 2021. As we can see here, the SIPOC flow diagram. There is a lot of parameter that use to understand and identify the problem that using for the bread making process. From here, we know that a lot of parameter that we using to control the problem. So what the most problem here is demand of the flow in bread making line, which is this is increase the raw material price. This is happen during the restrictions in the transportation due to the pandemic COVID-19. And then the service tax also increased about 28% per month. This is large number that increase. Also, from the CTQ, there is more about 5% per month, but this one is more about it. And then the VOC on this company are taken from internally and mine externally. Let's move on the measure of base. As we look at figure 6, the total flow usage per month, as we can see here in 20 months, the actual using of flow is increased about 440 or 450. And then if we look at the required is actually the low about 300 plus. Let's look at figure 7 about the flow divisions rate. As we can look here, in the month of 9, the flow divisions reached up to 60%, and then the second following is in the month 18, about 40%. Have looked at here the process in figure 8 about the process capability analysis by using Minitab. As we can see here, the within and then this one the overall, we can see here the potential with the capability, the CP about 0.21, CPL, CPU and CPK is the same number. Unfortunately, in overall capability in PP, PPL, PPU, PPK are different by this measurement. Let's look at the analysis space. As we can see here, the highest loss quantity per month, the biggest one is the ovens, which is there is the 31.6 kilo per month loss. As we can see and know about the type of defect here is the of course the pasting on baking container. And then the second one, the packaging, there is 3.7 kilo because of the high humidity, about 13.72% for the flow loss area and type of defects. Let's look at figure 10 about the Pareto flow loss area. The first, as we can see here, the percentage about 100%, and then this one is from the oven, and then the second one is the mixing equipment, where is about 39% of losses. As we can see at the figure 11, the Pareto chart, defect type in area. If look at here, the pasting in container, whereas the tremendously increase, as we can see the percentage here. So that is why we need to take more about the oven and then the packaging problem. From the analysis by using the backbone fish or fishbone about the cause and effect, there is the lot of parameter that we need to take care about the environmental, machine, management, maintenance schedule, and then the motor power and the material. So let's look at the big pictures of this fishbone that affect to the loss of the baking pasta. Okay, let's look at here. The causes of loss of flow. There is a lot about one lot of effect, but the most important here is the lack of inspection, maintenance, temperature, and humidity that make them lose lot. Okay, as we can see that many of the problem that outcome from the investigations, now we come out with the proper solutions based on the root cause identified. So here is a lot of uh, improvement or actions that we suggest, starting from the oven template and heater until to the lack of inspections. The most need to carry forward is the oven template and heat. There is the lot of 0.43% of the losses from this item. And then the second is the packaging. There is the 34%. The effect determines of the dough mixing leads the dough to be worse. So two of it is need to consider more at understanding. Let's look at the proposed solutions based on the root cause identified. Let's look at here the graph show us the CPK value about 0.07, and then the positive result impact with the incremental of the 233%. The previous both CPK and CPK value are 0.21. It means that they have a 233% for the improvement. And then this result will be substantial part of the process. Input might be out of the specifications, but in the future, improvement can still be executed to reduce the flow deviation rate. We can see here the SL, LSL, and USL that will be plotted. Let's look at the control path. In order to consist an efficient result, there is some point that we need to take care about the maintenance, about the process. The project will be monitoring about 6 months, and then all the detail will be recorded and passed to the others to review this project or the process, and then lot of improvement and writing communications will be included. Not only that, also there is a sum of the method that using, starting from the process control plan until to the financial costs also need to be reviewed if one more complete documentation. We in the final the conclusions. The first conclusions from this experimental is the Six Sigma using DMIC approach the shop, and then the problem of increasing flow demand will be revealed. Then minimize the defect rate and reduce for the waste to achieve for the more profitable margin. So from the reducing will be increase the profit of this company. The third one is results suggest substantial part of the process input, and despite having a increment of CP value after the improvement took place. And then the fourth one is from the implementation of Six Sigma by using the MIC method. The percentage will be increased to 233% from 0.21 to 0.70. That's it from me. Thank you for your patience.